Last class we are discussed about 2-bit ripple up counter and a down counter using negative edge triggered flip-flop. Today we will discuss about 2-bit ripple up down counter using negative edge triggered flip-flops. Here as the name indicates, an up down counter is a counter which can count both in upward and downward direction. Here the up down counter is also called as forward or backward counter. It is also known as forward or backward counter or bidirectional counter. Bidirectional means both upward or downward direction we can count the number. And so here a control signal or a mode signal, the control signal or mode signal, that is M, is required to choose the direction of the count. There are two directions. One is upward direction, second one is downward. So we want to either it as a upward counter or a downward counter. So we need to select the direction. If it is either upward or downward, that will be done by the mode control signal or mode signal M. When M is equal to 1, what about M is equal to, M is a one value, so it is either 1 or 0. So what happen if M is equal to 1? M is 1, then it is up counting. M is equal to 1, then up counting. Here M is equal to 1. If it is 1, then it is here. Then Q1 is transmitted to the clock input of the flip-flop 2. When M is equal to 0, then if it is applied to 0 here, then it is converted to 1. Then that 1 is given to here. Then Q1. If M is equal to 0, this will become 0. So this AND gate is not working. If M is equal to 1, only this AND gate is working. If M is equal to 1, here it is inverted, so it is 0. Here it becomes 0. So this NAND gate will not work. So here the first flip-flop output is connected with the Q1 is connected with this NAND gate. So it is given to the clock input of the flip-flop 2. So this is upward counting. So upward counting processes take place. Then next, if M is equal to 0, then 0 comes here. So this NAND gate will be not work. And here it is inverted, so it is 1. So here becomes 1. And Q1 dash will be given to here. So this AND gate will be work. And that clock input will be given to the flip-flop 2, and this Q1 dash output will be drive the flip-flop 2 or activate the flip-flop 2. So this indicates the downward counting. So the Q1 dash is transmitted to the clock of flip-flop 2. So this is achieved by using 2 NAND gauge and 1 OR gauge. So external clock pulse is given to the clock of the flip-flop 1. And here the clock signal, how to find out the clock signal of F2. F2 clock signal is, if it is Q1, so Q1, here it is considered up, Q1 up, here plus, OR gate is indicate plus, and here it is Q1 dash down into down, that is the equation. So it is up means M is equal to 1, so Q1 M plus here Q1 bar down means M is equal to 0, so M bar. So the clock signal to flip-flop 2 is equal to Q1 M plus Q1 dash M dash. So Q1 dash into M dash. So this is the explanation of 2-bit ripple up down counter using negative edge triggered flip-flop.